Hello everyone. Today let's look at an algorithm question. Find the longest palindromic substring. Let's see the question. Given a string S, find the longest palindromic substring in S. You may assume that the maximum length of S is 1000. We can see two examples at the right side. Before we solve this question, we need to understand a concept, palindrome. A palindrome is a string which reads the same in both directions. For example, string ABA is a palindrome because it read from the beginning to the end is ABA, and read from the reverse is also ABA. However, string ABC is not. Now please pause this video and think about how to solve this algorithm question. Today I will provide several solutions. The first easiest solution we can come into our mind is build force. For a string that length is n, we can find all the substrings and then check if it's palindrome. When we find the start index and end index of all possible substrings will be 2 iterations. And when we check if it's palindrome, we also need to check all the characters in that substring. So the time complexity for this problem would be O n squared. O n cubed. We can see a program implement this solution at the right side. We can think the build force is not a good solution, so we can think another way. Consider a case ABA. This is the palindrome. If we already know that the BAB is a palindrome, it's obvious that ABABA must be a palindrome since the two left and the right-hand letters are the same. So we can see that the substructure is almost the same structure as the bigger results. Then for such a problem, we can use dynamic programming to solve. Now we define the Pij as following. If the substring Si to Sj is a palindrome, we define Pij equals true. Otherwise, we define it as a false. Then we can see that Pij, it can equals Pi plus 1 j minus 1, and Si equals Sj. This is the mathematical expression of last description of this idea. For the dynamic programming, we need initialization. So the initialization case are Pii. We can think that only one letter that must be true. So Pii equals true. The other is Pi plus 1. If the Si equals Si plus 1, then Pii plus 1 will equals true. Otherwise, it equals false. So using this initialization and also this formula, we can write dynamic programming The code will look like the right side, implemented in Java. Using dynamic programming, we can see that time complexity is O(n) squared. And also the same space complexity also O(n) squared. This is a much better solution than the previous brute force solution. The third solution is expand around the center. We observe that a palindrome mirrors around this center. So we can, if we find a palindrome, we can always expand from the center to check all the possibilities. So there will be only 2n minus 1 such centers in a string that length is n. You might be asked why there's 2n minus 1 but not n centers. The reason is that the center of a palindrome can be in between two letters. Such palindromes have even number of letters, such as A, B, B, A, and its center are between the two B's. So this is a better solution for this problem. The time complexity is also the O(n) squared, but it's used less space. It's only a linear space used. That's all for today's algorithm problem. Thank you.